Hi friends, welcome to the third chapter in the series of learning Base SAS. And in the third chapter, we'll be looking at reading raw data from external files. Now, one way one way to provide SAS with data is to have SAS read the data from a text file and create a SAS dataset. Some SAS users already have data in a SAS dataset. If this is just the case, you can skip this tutorial and move ahead to the next one. Now, SAS has different ways of reading data from text files, and depending on how the data values are arranged, you can choose an input method that is most convenient. Now you have already seen one method which is called as the list input that was used in the first tutorial, in the introductory tutorial. Now in this chapter we will discuss uh, the list input as well as two other methods that are appropriate for data arranged in a fixed column. Now let's look at reading data values which are separated by blanks. Now, one of the easiest method of reading data is called the list input. By default, SAS assumes that the data values are separated by one or more blanks. Now, let's say the task in hand is you have a raw data file which is called as mydata.txt, and that's, let's say, in one of our folders. For reference, I'll use the learn folder, and we have the data as mydata.txt. So this is the data file. Now these values, what you see in the text file, these values are represented by gender, age, height, and weight. Now notice that this file meets the criteria for list input. That is, each data value is separated by the from the next by one or more blanks. Now, now in this current program, I have already typed in to save some time. Uh, as you see here, this program will read the data from the current txt file, and it creates a data set. Now let's examine the details about each of the statement which has been given here. Now let's start with the infile statement. Now the infile statement tells SAS where to find the data. The input statement contains the variable names you want to associate with each data, and the order of these names match the order of the values in the file, which is the dollar sign following with the gender. It tells SAS that the gender is a character variable here. Now, to see this program work properly, we have added the prop print data. So this step will list the observations in the SAS dataset. So if we run this program, okay, So as you see, there is the output. Now each column in this output represents a variable in the data set, and each row represents the data on a single person, which is called as an observation. The first column, labeled as ops, which is observation, which is the short form for observation, is generated by the proc. The values in the column go from 1 to the number of observations in the data set. The order of rows in this list change. Uh, sorry, the order of rows in this list would reflect the order that the observation were read from the input data and created in the data step. Now, if you change the order of the observation or add new observation to the data set, the number of observation column may change. The order of the variables, the columns, reflect the order that the variables were encountered in the data step. Now, let's look at uh, when we have when there are missing values in the list input. Now, what would happen if you didn't have the values for age for the second subject in your file? So, in terms of representation, so this is, suppose you don't have these values. So what would happen? Then the data file would be looking like this. Now, uh, it should be obvious that this will cause error. Now, SAS reads the value 60 for the age and then 101 for the height. And because there is no more values on the second line of the data, the SAS goes to the next line and attempts to read the M as the height value, and this causes the error. Now, clearly we need a way to tell SAS that there is a missing value for age in the second line, and one way to do this is to use a period to represent the missing value. So a period is just the dot. So this is what it would look like for a missing value. Now, you must separate the period from the values around it by one or more spaces, because a space is the default delimiter character. Now SAS now assigns a missing value for age for the second number. By the way, missing value is not the same as 0. This is important because if you ask SAS to compute the mean, or basically the average of all the ages for all the subjects, then it would average only the non-missing values. Now, you can use a period to represent a missing character or a numeric value when you use a list input. Now, let's look at reading data values which are separated by commas, or which is called as a CSV file. Now, a common way to store data on Windows and Unix platform is in a CSV files. Now, now these files use commas instead of blanks as data delimiters. They may or may not enclose character values in quotes. Now let's look at a CSV file. Okay, so sorry, I'll open it in Notepad. So this is how a CSV file looks, and it contains the same values as my data.txt. Now let's see a program about reading the data from a CSV file. So now this is the program. Now here, if you notice that the infile statement in this example is basically followed with a DST. Now the DST is basically the delimiter sensitive data, which is following the file name, and it performs a several function. First, it changes the default delimiter from a blank to a comma. Next, if there are two delimiters in a row, it assumes that a missing value between them. Finally, if a character value are placed in quotes, which is basically a single or double quotes, the quotes are stripped from the value. So these are the three functions of those DST, and that is just three letters doing a lot of these functions. Okay. Now let's look at using an alternative method to specify an external file. Now we have been using INFILE. Now INFILE statement, as you see in this program, it used the actual file name which is placed in the quotes to specify our raw data file. Now an alternative method is to use a separate file name statement to identify the file and to use this reference in the infile statement instead of the actual file name. So this is an example of that. Now if you notice, there is a file name Preston which is mentioned, and it is referring to my data.csvs. Now the name, if you see, which follows the file name statement, is an alias for the actual file name. For certain operating environments, the file ref can be created outside of SAS, and for example, maybe in a DD statement in a JCL on an mainframe. But you notice also that the file ref pressed in the infile statement is not placed in quotes. So this is how SAS knows that Preston is not the name of the file, but rather a reference to it. Now let's look at reading data values which are separated by delimiters or other than blanks or commas. Now remember that default data delimiter for list input is a blank. Now using the infile option DSD, it changes the default to comma. Now, what if you have a file with other delimiters such as tabs or columns like that? Now, you only need to, in these cases, you only need to, add the DLM equal to option. Okay. Now, for example, uh, let's say the lines of data that we have seen earlier. Uh, just a sec. Okay, so this is there. Let's edit this file itself. So instead of the comma here, you'll be using semicolons. Okay. So now in such cases, to read such sort of file, the infile, uh, then we can have the file descriptor, then we can have the DLM equal to the semicolon. So these you can spell out the name of the delimiter equal to option as DLM, like I mentioned. So now tab, when we are looking at tab, it presents a very interesting problem. Like what character that you should be placing between the quotes on the DLM equal to option. Now you cannot place the tab key instead. And what you have to do is it needs to be represented by the tab's hexadecimal equivalent. Now for ASCII files, the coding method which is used on Windows platform and Unix operating system, uh, it is 9, uh, yeah, it is 9x. So that is how you have to represent with a DLM in terms of a tab. Now let's look at placing data lines directly in your program. So now, suppose you want to write a short test program in SAS. Now instead of having to place your data in an external file, you can place your data lines directly in your SAS program by using the data line statement. Now, for example, if you want to read the data from text file, mydata.txt, that's our standard file. Okay, and you don't want to wait to go over the trouble of writing the external files. So in this case, this is the example how you can write a program and include the data directly into it. Now let's understand the program. Now as you see from this example, the infile statement was removed and a data line statement is added. Now following data lines, you see the lines of data. Now finally semicolon is used to end the data step. Now the lines of data must be the last element in the data step. Any other statement must come before the lines of data. So that is one of the principles. Now while you'd probably not use data lines in a real application, it is extremely useful when you want to write a short test program. Now so if we need to execute it, let's just go ahead and execute it and show you. Okay. Now let's look at specifying infile option with data line statements. Okay. Now, what if you use data line and want to use more than one or more of the infile options, such as DLM equal to or DSD? Uh, you can use many of the infile options with data lines by using a reverse file reference called the data lines. Okay. Now, for example, uh, let's say if you wanted to run the example that we had in 3.2, uh, this without an external data file, you could use the program in this particular format. Now let's look at reading raw data from fixed columns. Now the first method in this is basically which is called as the column input. Now many raw data files which are stored in specific information is stored in a specific column. Now this has several advantages over data values which are separated by delimiters. First, you don't have to worry about missing values. If you do not have a value, you can leave the appropriate column blank. Next, when you write your input statement, you can choose which variables to read and in what order to read them. Now, the simplest method for reading data in fixed column is called as the column input. Now, this method of input can read character data and standard numeric variables. Now, by standard numeric values, we mean positive or negative numbers as well, and as as numbers in as well as number in exponential forms. Uh, this form of input cannot handle values with commas or dollar signs. Now you can only read data as sorry you can only read um, yeah, you can only read the dates as character values and with this form of input. Now suppose you have a raw data file which is called as bank.txt. Okay. Now in this file, let's see what is the content. Now in this, as I mentioned, everything is organized in columns. Okay. Now let's look at the program in terms of reading this file. Now in this program, if you see, you can specify a variable name, a dollar sign if the variable is a character value, then the starting column and the ending column. In this program, the number of columns you specify for each character variable determines the number of bytes that SAS uses to store these values. Now, for a numeric variable, SAS will always use 8 bytes to store these values, regardless of how many columns you specify in your input statement. Uh, Also, you notice that this program uses separate lines for each variable. Now, this is not necessary. You can put all of the variables, everything in one line. So, if we run this, so this is the output. Now, it is important to remember that the date of birth is a character value in this data set. Now, to represent, now to let's say create a more useful numerical SAS date, you need to understand formatted input. Okay. Now, let's look at reading raw data from fixed columns, which is the formatted inputs. Now, formatted inputs also read the data from fixed columns. Now, it can read both character and standard numeric data as well as a non-standard numerical data, um, such as numbers with dollar sign and commas and dates in a variety of format. Now, formatted input is the most common and powerful of all the input methods. Anytime you have a non-standard data in a fixed column, you should consider using formatted input to read the file. So in this case, let's start with the same raw data file that we have, which is bank.txt. And let's look at how does a formatted input look like. Now, if you see here, in the program, yeah. Now there is at sign in the input statement, and it is called as the column pointer, and they just do same thing as the job of a pointer. Now, for example, at 4 says to SAS to go to column 4. Now, following the variable names are SAS informats. Now, informats are built in instructions that are so that tells us how to read the data value. The choice of which format to use is dictated by the data. Now, two of the most basic informats are w.d and $w. Now, the w.d informat reads standard numeric values, and the w tells SAS how many columns to read. The optional D tells us that it is implied a decimal point in the value. Okay. Now, for example, now if you have the number 123 and you read it with a 2.0 in format, SAS stores the value 123.0. Now, if you read the same number with a 3.1 in format, SAS stores the value 12.3. Now, if this number you are reading already has a decimal point in it, then SAS ignores the D portion of the informant. So if you read the value 1.23 with a 4.1 in format, SAS stores the value of 1.23. Now the $w.informat tells SAS to read W columns of character data. Now in this program, the subject is read as character data and takes up three columns, which is values of gender, and takes then the values of gender, it takes up a single column. Now, if you read the value 0101 1960 with a DDYY10 dot in format, SAS would store the value of 0. The date, which 0102 1960, reads the same in format would result in the value of 1 and so forth. Now SAS knows all about leap year and correctly converts any data from 1582 to the way of future. Okay, um, that is this date of 1582. You might ask why, because 1582 is the year Pope Gregory started the Gregorian calendar, and dates before this are not defined in SAS. So, okay, now getting back to our example, now since date values are in the MMDD YYYY format or form, and it starts in the fourth column, you use @4 to move the column pointer to the column 4, and then the MMDDYY10 dot in format tells SAS to read the next 10 columns as date in this form. Now SAS then computes the number of days from 1st January 1960 corresponding to each of the date values. So if we see the result, now the date looks rather strange. What you are seeing are actual values SAS is storing for each date of birth. Now you need a way to display these dates in a more traditional form, and as the way the dates are displayed in the raw data file. Or in some form, maybe such as 10th October 1955. Now, while you are thinking about it, so why not add a dollar sign and comma to the balance figure? Now you can accomplish both of the task by associating a format with each of these two variables. There are many built-in formats in SAS that allows you to display dates and financial values in a proper readable ways. Now you can associate these formats with the appropriate variables in a format statement. So let's look at a format statement, and this is a basic way of how you put a format statement. Okay, now you see the output here. Now, in the output, if you see here, you have the MMDDYY10 dot format. Now, to print the date of birth values, which is the DV values, and then the $11.2 format to print the balance values. Now, notice that the period in each of the formats. Now, all SAS formats need to either end in a period or in a period followed by a number. Now, this is how SAS distinguishes between names of variables or data set and the names of the formats. Now the 11.2 following the dollar format says to allow up all to the 11th columns of to print the balance values then. Now the 2 following the period says to include two decimal places after the decimal point. Now it is important to remember that this formats only affect the way these values appear in a printed output, and the external values are not changed. To be sure that you understand what formats do, let's repeat the program here with another format of date of birth. Now, if you look at this program and check out how does it produce the report, okay. Now, this 9 dot date 9 dot format prints date as a 2-digit day of the month and a 3-character month abbreviation and a 4-digit year. Now, this format helps to avoid confusion between month, days, and year, and date, months, and year format, which is basically used in, let's say, United States and then in Europe, respectively, and basically also in India, we have the other way of putting things, and this can be also accepted. Now notice also that the $11.2 format makes the balance figure much easier to read. Now this is a good place to mention that the comma W.D format, which is useful for displaying large numbers with commas. Now let's look at using informats with list input. Now suppose you have a blank or a comma delimited file that contains date and character values longer than 8 bytes, or the values that or yeah, let's say it's longer than 8 bytes. Now one way to provide informat with list input is to follow each variable name in your input statement with a colon, now followed by an appropriate informat. Now to see how this works, now suppose you want to read a CSV file which is list.csv. Let me open that file for you. So let's consider this file list.csv. Now variables in this file represent subject number and name, then date of birth and yearly salary. You need to supply informats for name, date of birth and salary. So let's see a program and how to do that. Now you see here that so you see that there is a column preceding each informat, and these columns are called as informat modifiers. It tells us to use informats supplied, but to stop reading the values for this variables when a delimiter is encountered. Now, do not forget that the colons, because without them, SAS may read past a delimiter to satisfy the width specified in the info format. Now, this program would also work if the info format for subject is omitted and the variable name was followed by a dollar sign. However, the subject variable would then be stored in 8 bytes. Now, by providing the $3 dot in format, you tell SAS to use 3 bytes to store this variable. Okay, let's just execute this. So you see it works perfectly. Now let's look at supplying an informat statement with list input. Now another way to supply informat when using list input is to use an informat statement before the input statement. Uh, Now, following the keyword informat, you list each variable and the informat you want to use to read each variable. You may also use a single informat for several variables if you follow a list of variables by a single informat. Now, to see how the program actually works, check out. Now, in this program, it uses an informat statement to associate an informat to each of the variables. Now, when choosing informat for your variable, be sure to use the length long enough to accommodate the longest data value you will encounter. Now, notice that the input statement does not require anything other than the variable names because each variable already has an assigned in format. Now, a listing from procprint will also tell us that. Let's first execute this. Okay, now let's look at using list input with embedded delimiters. Uh, Now, what if the data in the previous CSV file, which is this, uh, was replaced in a text file where the values were used as the delimiters instead of commas, and there were no quotes around each character? So, to actually represent that, we'll open up the list.txt here. Okay. Now, if you look at this file, then you say that okay, we have a problem. But if you try to read this file with a list input, the blanks in the name field will trigger the end of variable. Now, SAS came up with a very wise way of solving this problem, and it's known as the ampersand format modifier. Now, the ampersand it looks like a column. Okay, so this is the sign if you don't know it. Now, the ampersand sorry, now like the column, it says the supplied in format, but the delimiter is now about two or more blanks instead of just one. So if you use an ampersand modifier to read the list.txt file here, you need to use the ampersand modifier following the name. Now you'd also need to have two or more spaces between the end of the name and the date of birth. Okay, so let's just execute the prompt. Okay, so this is how it works. Okay, so that would be all, and I'll get back in the next tutorial in the series. Till then, thank you.